What's up, guys? This is Jeff from Evans Tuning. So it's been a while since I've uploaded any technical information to this YouTube channel, so I owe you guys a really good video. So I'm going to be sharing with you how to tune a Hondata S300 system using a Lambda Overlay feature. Now, this video is from my online tuning school from Evans Performance Academy. I wanted to share it with you to obviously give you the technical information, but also so you can see the teaching style that I use in my videos for my online school. So I cover a ton of different systems and topics. So whether you're going to be an import guy or a domestic guy, if you're using Hondata or HB tuners or a standalone like AM Infinity, I cover all of those systems with this online school. So if you're sick and tired of dealing with multiple different tuners that can't get your car right, or if you're sick and tired of just not having a tuner near you that's really good, take the matters into your own hand. Anybody can tune their own vehicle. And with these videos, I show you the basics and we walk through a process and we get up to the system specific courses. So you're gonna be able to use whatever system you want to tune on your vehicle, and you're gonna be able to know exactly what to do and do it with confidence. So whether you're gonna be tuning your own vehicle, tuning your friends' vehicles, or you want to do it professionally, I'm going to give you the opportunity and the knowledge how to do that with these videos. So without further wait, let's jump into this video so you can check it out, and stay tuned to the end because I'm going to be talking a little bit more about this online school. Welcome to Hondata S300 Training Part 19. In this video, we're going to be looking at the Lambda Overlay feature found in our S Manager software. We have a lot to learn, so let's get started. Okay, so let's jump into this video and start talking about our Lambda Overlay feature we're going to find in our S Manager software. Now, the overlay is going to allow us to take a wideband input and then build our fuel table very quickly. It's going to be able to compare the difference between a target air fuel map and our actual air fuel and show us how much we need to change our particular fuel map at that point by a certain percentage. So we're going to be able to populate our fuel table very, very quickly using this Lambda Overlay feature, and it's going to be an essential tool you're going to have in tuning your S300 correctly. So let's jump into this video and see how the Lambda Overlay feature is going to work and how we're going to be using it. All right, so let's get into this video and talk about our different calibration techniques we're going to find for setting up and tuning our main fuel table. So we're going to go in here and jump in and grab a calibration file. So let's grab a P72 file and click OK. So we have two different options or choices when we're going to be tuning in the S300. We can tune our fuel tables here in an open loop format, or we can tune them in a closed loop format. Now, if we're going to be using the open loop style of tuning, we have a really trick way of going in and setting up the fuel map to the exact air fuel that we want so that there's no guesswork. We're going to utilize the input, and it's going to show us how much we need to change in our fuel table. So let's go ahead and look how the first process is going to work if we're going to be an open loop tuning method, and we're going to not use a closed loop method where we let the ECU actually make the adjustments for us. Okay, so the first thing we need to do is go up into parameters. We're going to make sure that we set up the wideband coming into our particular engine. So if we go and look under our closed loop here, advanced, either we're going to set the input source for this D14, and we're going to set our offset, and then we're going to set our voltage to air fuel scale for the wideband that we're using, or we can go in here and we can go into our analog inputs, and we can go and set this up as a wideband coming in into one of the analog inputs that we wire our 0 to 5 volt signal wire from our wideband. So we can do either or. Now the next step, if we want to put it in open loop and use this method, is to go in here, click open loop, click disable O2 heater, and then we're ready to start using this Lambda Overlay option. So let's go ahead. I'm going to go and get live here with my S300, and I'm going to just get the engine running here. Okay, so we can see here my air fuel is right around stoichiometric of 14.8. Now we have these three tables here that we can work with for using this Lambda Overlay option. So the first table here, this is going to be showing us the actual recorded lambda, or the air fuel. So we can see here that it's 14.8, and we can see here in the table that it's 14.8. Now our engine is running at this exact spot. So we have this much map pressure, we have this much RPM, and it's plotting this for us right under the fuel table. Now if we look here at this first view, this is going to be the format that we're going to see where it actually has the raw fuel value in the table. And then if we look here, we click to the next window, it's going to display the actual air fuel. So if we go ahead and just going back and forth between these two, we can go ahead and just highlight this and still make changes in this window. We can see once we highlight it here, it's going to highlight the fuel table. And we can still use that Control J function and be able to change it by a percent, change it by an actual plus or minus amount, or change or set the entire values to a particular amount. Now we're going to be interested in utilizing this percentage adjustment for this style of tuning method because the rest of these aren't going to really apply, and we're going to see why that is in a minute here. So we can see if we just drive our engine around here, our air fuel, it's going to plot depending on our load as we sweep through the table. So we can see that it's going to pretty much tell us where we've been in our fuel table here, as we're doing our driving. So the key to using this is going to be do a bit of driving if you can when you're starting up on a fresh calibration file, as long as you're not super rich or super lean. And in that case, we're going to have to go ahead and take care of that right away. But if we're close, if we're in the 12 to 15 to 1 air fuel range as we're driving around, then we're going to be able to go ahead and just sweep through some of this tables, doing some light driving, or we get on the dyno. We're going to go ahead and fill out the majority of our table. Now, if we go ahead and look here at this percentage difference, so this is going to tell us, this is the lambda or the air fuel. So this is our actual air fuel that we're reading here. This is going to tell us the difference, or how much we need to change our fuel table based on the target that we want to actually run based on that particular load or RPM that we're at. So if we go into this target table here, we can see that in the lighter vacuum regions, so from -4 inches and down in vacuum, we're going to want to run at stoichiometric or 14.7. And then as we transition into more full throttle area here, we might want to run 13.5 air fuel. And then once we get into boost, we might want to run 11.5 air fuel. Now we can go ahead and configure what this target is in this table here. If we go under options, we go under settings, we go under target lambda, and then we can go into here where we have low, medium, and high load, and we actually specify where we want the air fuel to be in this table. So for example, if I want this to be at 15 to 1, below 2.5 inches of vacuum, we can see here that's the breakpoint. We can see here that was 14.7, so 15 to 1 below that. If I click OK, it's going to just re-update this table now with a new target. Now this isn't going to be a closed loop method, we're going to be an open loop again. So let's see what this is going to do. If we go into our difference map, and then we build this map up again, if we just drive through it, we're going to drive through a bunch of different points here, we can see that as we are going across here, this is going to be showing us how much difference we're going to have between the actual air fuel that we're reading here and our desired air fuel here in the table. So let's go back to here for a second. We can see, because we're going to be running, and on the simulator I'm running 14.7 air fuel, we're going to see that as we get into boost here, there's a 22% difference. And that's going to be a 22% positive difference that we need to add to our boosted sections here. So but 3 psi and higher columns that we have to add in order to get back to this 11.5 air fuel target here. So whatever we put for the target, it's going to show us the difference in this table of how much we need to adjust the fuel table by based on the actual air fuel in this table. So let's go ahead and look at just a quick calibration technique here that I can just show you. So let's go ahead, I'm going to go ahead and I'm going to lean out my air fuel a bit, and I'm going to just drive this up and down here. I'm going to sweep. We can see that our air fuel is actually here around 16 to 1. So let's look at this process. Let's just fill out our table here a bit more. So we're going to be doing some driving on the dyno. We're going to go back and forth. And then we're ready now to make some changes. Okay, so for this example, again, I'm on a simulator. This is just fixed at an air fuel right now of like 15.8, 16 to 1. We can see that our vacuum portion right here, showing that I need to add 7%. All we're going to need to do is just highlight this section here, Control J, and we're going to add whatever it's telling us here to the fuel map to get our air fuel. So let's go ahead and just add 7%. If we click that and click OK, we can see that our whole fuel map's been raised up. So let's go ahead and drive it some more Let's get into some higher load sections here. Let's go up in these regions right here. Let it populate some values. As we drive, it's going to keep changing and changing some more. Let's get up into about 0 psi here. We can see they're still lean at 16 to 1 in this particular example. So let's go ahead and just keep going through here, sweeping some more. Okay, now we've filled in the table approximately. And again, because our air fuel really isn't changing, because we're on the simulator, we're going to find that it's plotted now, the actual difference we need to change. So we can see here in this column, it looks like we're about 4 to 5% we have to add. So let's get Control J and add 5% here. And then we can see in these columns here, it's showing we have to add between 13 to 16%. Let's just go ahead and just go add maybe something like 12 or 13. And then let's go and start trying to get maybe into some boost here. Now obviously, if we saw that it was lean at 16 or 15 to 1, it's going to really be rough if we try to get into boost, and it's not going to be ideal. So if we saw that if we started to tip into boost, it looked like it would be rich, we would go ahead and correct that before we'd actually try to do any pulls in boost so we didn't damage the engine. But just for illustration purposes here, let's go ahead and just sweep through here again and try to fill some of this table out. Now obviously, this would be more of full throttle effect as we're driving. So it's gonna, as I'm doing part throttle sweeps, it may not be realistic. So being able to do this in a steady state condition on the dyno. But let's just assume that we did that same technique where we populated the table. Now we can see that we have to add around 28% because we're at 16 to 1 air fuel. And again, our target is 11.5. So it's showing us the difference automatically. So we'd have to go ahead and select our boost portion of the map. We click something like 28%, and now we can see that we've effectively added in what it's telling us that we need in our fuel table to be able to get to these target values compared to what's coming in on our actual wideband. Now, if we build up this table and we can see that it's clustered, it has all this values populated, if we want to clear the entire table out to begin the process again, we're going to hit Control L, and that's going to clear the entire table out. It's going to go make that all cleared out again. So we can go ahead and do that same process of repopulating the data and driving through. Now, once we've updated it, it's going to give us values that are more appropriate. So we can see, let's just say, for this particular example, we corrected it, and now our air fuel here is at 14.7, 14.8. We can see that it's showing a 0% difference of what we should add in these kind of areas because we've went in and got it back to that stoichiometric target of 14.7, 14.8 here at part throttle, because if we look, we have right around 15 to 1 air fuel as our target, and we're hitting right around 14.9, 15, so we're very, very close. And if we get up into some of these columns here, we can see that we might have to add some more fuel. So as you drive on a live engine, so if you're not on a simulator like we're on here, you're going to see that the values are going to change all over the place. Now the key to really populating this table correctly is to have a smooth throttle. You don't want to constantly pumping the throttle. You want to try to drive through these data points here as smooth as possible. And that's going to go ahead and just fill in the percentage difference. And you're going to use that highlight, Control J, and then you're going to go ahead and just add whatever needs to be added that it's telling us. And it's going to be a relatively simple process. So we're ready to take a look now at the next process of using a closed loop method with our O2 control so we can utilize that to populate our fuel table. Okay, so the next technique we're going to look at here is going to be our closed loop tuning technique. So we can use a closed loop tuning technique and still use our sensor overlay here, our Lambda overlay option, so we can see what it's going to do in boost and still be able to use that to quickly populate and set up our boost portion of our table. But this is going to be more of a part throttle thing that we can look at and utilize for our part throttle tuning if we're going to run in full closed loop method. So we're going to first go in and just go into parameters. And we're going to go into our closed loop. In this particular case, we've wired a wideband in, so I'm going to assume it's on D14 here. We set up our scale. This is just an AEM gauge that it has a 0 volt is 10 air fuel, and 5 volt is 20 to 1 air fuel. We go into closed loop. We're going to select our closed loop wideband input voltage target. I'm going to go ahead and set our stoichiometric, our wideband target value here at 2.5 volts, which is 14.7 on this particular wideband. So it's a 30-4100 part number from AEM that we're going to be utilizing. And we're going to set our maximum map for closed loop. Let's set it something like -2 inches. Let's set our maximum speed at something like 6,000 RPM. Let's set our throttle input here to something higher, like 50%. And let's go ahead and set our long-term trims to something lower, maybe 5 on the maximum adjustment, and then maybe something like -5 here. Let's just leave it at 0. Doesn't look like it's going to let me update that. So our minimum short term, let's put it at like -15 and then something like 15. And let's go ahead and update our switching voltages here. So we're going to make these all 5, make these all 30. This is going to slow down the response rate from our wideband as it's coming in, because if we leave it with a fast switching response from rich to lean, it'll really throw off our closed loop method. Now, let's look here at how we can utilize the closed loop to tell us what we need to do. So we can see up here our short term here is at -14%, and we're achieving our target here of 14.9, which is essentially what we had here, around 15 to 1. So if we look at our sensor overlay here, this would say that we're at 0, or essentially -1, or essentially no correction at all. But our short term is telling us that we actually have to take 14% out, because again, it's correcting for us. It's taking this much fuel out of our fuel table here, and it's getting us back to this 14.7 air fuel that we want to be at. So if we just paid attention to our short-term trim here, and we just drove very slowly in RPM, we can see that it's at a relatively fixed value here. And if we just go ahead and we altered our RPM here a little bit, we can see as we're coming up and down, we can see that based on the O2 voltage target, it's adding now 14% depending on where we're at. So we can utilize the O2 sensor feedback to actually dial in our fuel table when we're doing our tuning. So we're going to pay attention to this short term, and we're going to correct the table by whatever it's telling us, whatever load and RPM point. Now, we're not going to have it trace through and show us the exact percentage it needs to be changed by, because again, it's going to be trying to get us back to that stoichiometric point here, or wherever we're going to be setting that target lambda voltage. If we go back into our parameters here, whatever we said, this wideband target voltage, so 2.5 volt on this particular wideband corresponds to 14.7. It may differ depending on the wideband that you have, but it's going to be wherever we set the target at, it's going to be holding us there in our short term. So we can't really use this percentage difference feature, because we're going to be essentially hitting that 14.7 target right here in our partial throttle operation. But we can use the short-term percentage and use take out the fuel. So if we had in this example, just looking at our main fuel table here and paying attention to this percentage adjustment, we might take out 12% because it's saying that we're too rich. So if we drive it through at different points, we would have to hold the engine at different data points in the RPM band and see what it was saying. So we can see here as we drive it, the fuel trim is changing a bit depending on where we go. If we get up here out of closed loop, we can see that our short term effectively zeroes out because we're out of that threshold with load that we've programmed here. We go back into our table here, we've programmed it to -2 inches or -2 psi or -4 inches of vacuum. We switch out of closed loop and above 50% throttle or above 6,000 RPM. So we can still utilize this closed loop method to really populate our vacuum driving, and then go switch back to this percentage different method, because we're going to kick out of closed loop and it's going to show us the percentage difference from our target to whatever we programmed it here. So we can still utilize that at our full throttle or higher load tuning. So again, if we get up into here, we can see that it's going to show us that percentage difference, and that's going to be accurate because we're not going to be utilizing closed loop to try to get us back to a target air fuel. We're going to be an open loop at this point, and we can still use this using this populated method to go up and down and sweep and figure out what our difference is at wide open throttle conditions. All right, so hopefully that video helped you guys out in learning how to work with the Hondata S300 system, utilizing that Lambda Overlay feature to build our fuel table. So now if you're an import or domestic guy and this video really didn't apply to you, hopefully you can see the amount of detail and knowledge I packed in just one of these training videos. And this is going to be in a whole course. So this Hondata S300 video is part of a around 30 video course, and it's about 8 to 10 hours long. So we're going to be offering a ton of other courses. So on the standalone side of things, we have AEM, Motec, Haltech, Holly, Fast, Megasquirt, and a bunch of other systems. And then on the OEM ECU side of things, we're going to have HB tuners and SET for GM and Ford. So we're going to be packing a ton of information in all of these online courses. I actually have another full-length video. If you're using an AM Infinity system, you can check out. I'm going to put the link in the description below. It's going to be how to use the AM Infinity using the Flex Fuel feature, and I cover that on my other channel of Evans Performance Academy. So again, check out that link so you can see another full-length video if you want to check out some more tutorials that I have available. In addition to that link for the AM full-length video, I'm also going to be adding a direct link to the online school's content page. So you're going to be able to see all the videos that we have currently available to the subscribers. We have about 50 hours of content right now. We add about 4 to 6 hours of content each week. So you're going to have a ton of fresh content coming in as you subscribe monthly. Now, if you don't see the course that you're interested in learning from, we're going to have a newsletter. I'm going to have the link as well in the description. You can join our monthly newsletter that I send out, and that's going to announce any of the future courses coming out in the upcoming months. So I send that out about once, maybe twice a month. I'm not going to spam your inbox if you join it, I promise. So make sure that you go and subscribe to that. So for all of my Evans Tuning YouTube subscribers, I'm going to be giving you guys an exclusive offer here to be able to enjoy this online school and be able to save some money. So using this coupon code, you're going to be able to save 10% each month on the first year of your subscription. So hopefully you guys liked this video and it was very useful. So make sure you give it a thumbs up. Make sure you share it with your friends. Make sure you subscribe to this channel. I have a bunch of fresh content coming out this fall and you're not going to want to miss it. So I will catch you in the next videos.